Captain, we need to find out who or what did this. If we don't find out, the safety of the whole crew could be at stake.
Let's talk in my cabin.
Start from the beginning, Captain. What was the ship carrying?
A cargo of crude. We loaded as normal. We've carried the same type of cargo many times before. Arabian crude. Not known as particularly toxic or dangerous. I briefed the chief mate, and he posted the MSDS as normal. We also posted warning notices on the gangplank to inform crew, shore personnel, and visitors. Everything should have gone to plan.
You were right behind Leonard when the accident occurred. What were you doing?
Well, it was all routine, really. Leonard was going into the store to study cargo sample bottles. As he went in, Sam, who happened to be passing, complained to me of a horrible sting.
Was Len wearing any special clothing? Or breathing apparatus?
No, nothing like that. It was just a routine task. When he didn't reappear, I got worried. So opened the door and he was just lying there. I called the bridge right away and we mustered an emergency party to get to him. But it was too late.
And did you notice anything?
A funny smell, like bad eggs. But I was more concerned about getting him to safety.
If he died of what I'm beginning to think he did, you're lucky to be here to tell the story.
It happened right on deck. He was gauging the tank for water. There was quite a bit of vapor coming from the bulb. Then he rubbed his eyes as if something was irritating them. He clutched at his throat and then just keeled over. By the time I got to him, he was dead.
Shouldn't he have been using a closed method to gauge the tank?
Well, yes, but he was in a bit of a hurry. So, well, decided not to bother.
Was he carrying a gas detector? Or wearing one?
No, not that I could see anyway.
Let's examine the evidence. We're searching for a killer that's not only lethal in enclosed spaces, but also open areas. There was no smoke, so what we're looking for must be a gas. But which one? This gas caused drowsiness, and victims experienced eye and throat irritation. What convinced me of the nature of this killer was the smell of bad eggs noticed in the locker room. There can be no doubt about it. Your killer is hydrogen sulfide.
Hydrogen sulfide, H2S.
Hydrogen sulfide is one of the most dangerous gases there is, made worse by the fact that it's colourless and lethal in very low concentrations. The safe exposure level for hydrogen sulfide is very low, just 5 parts per million. Even at concentrations as low as 100 parts per million, exposure to the gas can be fatal, making hydrogen sulfide deadlier than carbon monoxide and almost as toxic as hydrogen cyanide. At levels greater than 700 parts per million, sudden death can occur with just a few breaths. It really is that dangerous. The only warning you get is the smell of bad eggs. But at over 100 parts per million concentrations, this smell soon disappears because hydrogen sulfide numbs your sense of smell. You think the gas is dispersed. It hasn't. If you smell hydrogen sulfide, you have to get out of the vicinity, and quickly. To make it worse, at concentrations over 500 parts per million, your sense of smell is numbed so quickly, you hardly smell the gas at all. If that's not enough, hydrogen sulfide at very high concentrations can form an explosive mixture with air or oxygen.
They were killed by hydrogen sulfide. How did it get there? Where did it come from?
A number of different places. Hydrogen sulfide occurs naturally and is produced by the decomposition of sulfur compounds. That means it's present in large quantities in gas and petroleum. Hence the danger of exposure on tankers in particular. But it also occurs as a byproduct of the ship's sewage system and could be present there or in the sewage holding tanks. Hydrogen sulfide can also be released from liquid in a storeroom if a sample jar breaks, for instance. What happened, I think, to the crewmen in the locker. The vessel's cargo ullage space and associated venting systems can also contain the gas, as can ballast tanks containing mud and sludge. It can also be present in a ship's heavy fuel oil, so there could be risks of the gas when bunkering, heating the fuel, mixing the fuel, and maintaining the fuel handling equipment.
So, where are we most likely to encounter hydrogen sulfide on board?
Speaking very generally, the gas tends to accumulate in low places in high concentrations. That's because it's heavier than air. But that doesn't mean you won't find it on deck as well. The risks are greatest when working with open hatches, such as when purging hydrocarbon gases in preparation for gas freeing, or reducing gas concentrations before arrival at the loading port. It can also be present when transferring cargo, bunkering the ship, and when inspecting enclosed spaces such as cargo, ballast, and fuel tanks, particularly after cleaning or maintenance. Hydrogen sulfide could be lurking in pockets in all these areas, and its effects, as we've tragically seen, can be fatal.
Hydrogen sulfide is a colorless gas, so you can't see it. And if it's in high concentration, you can't even smell it. So how do you know that it's there?
You'll know soon enough. You'll get a burning in the eyes. Your nose, throat, and lungs will experience irritation. You'll get dizziness, headache, and coughing.
So if it lurks in pockets, it's possible that one person might be all right while the other is affected. How would I know if, say, Don here is being affected by the hydrogen sulfide?
If he's being exposed to toxic levels of the gas, he'll move slowly. His speech will be slurred. He could be unable to understand what you're saying to him. He may be staggering or colliding with objects.
So, what on earth do we do to protect ourselves against hydrogen sulfide?
You must always be vigilant. Think for yourself if there's a possibility of the gas being present. And most importantly, follow strict onboard management. That means monitoring the cargo and checking on expected hydrogen sulfide levels. Study the material safety datasheet carefully for any special risks. Hydrogen sulfide can also be present in cargo holds, especially if you're carrying perishable loads. But the best way to protect against hydrogen sulfide is to use gas detectors. A few vessels today have fixed continuous gas detection systems, with sensors which activate an alarm when dangerous gases, such as hydrogen sulfide, exceed preset limits. Where ships don't have these systems, the first line of protection against the gas is the portable gas detector, which can work on the Draeger tube system or can be electronic. Belt-mounted or handheld, they give an audible alarm and in some cases a readout upon exposure to a predetermined level of hydrogen sulfide. Smaller, personal gas monitors can also be used. These clip to belts or pockets and indicate the concentration of hydrogen sulfide you're being exposed to. But whatever detector you use, care must be taken to ensure it's being operated correctly and that readings aren't affected by other gases.
So let's just say that we've detected hydrogen sulfide. How do we protect ourselves against it?
The only sure way is by wearing approved personal protective and respiratory equipment. There are three main types. The first is self-contained breathing apparatus. This supplies compressed air from a cylinder worn on the back to a full facepiece and should be of the type that maintains positive pressure in the facepiece. The cylinder itself must be rated to supply air for at least 30 minutes. Supplied air breathing apparatus is the second type. It supplies breathable air from cylinders or a compressor in a remote location free of hydrogen sulfide via a hose to a full facepiece, maintaining positive pressure in the facepiece. An emergency escape bottle must be worn with this type of equipment in case of an interruption of air supply. The third type is emergency escape breathing apparatus, which is suitable only for emergency use to provide breathable air for a short period of time. This apparatus is very portable and can be donned quickly if the gas is detected.
Okay, so let's say, for argument's sake, that there may be the possibility of hydrogen sulfide in an enclosed space. What precautions should we take?
The first thing you should do is let the officer in charge know. It's his decision whether to allow entry or not, and to issue instructions to ensure all the required precautions are taken. The space must then be carefully opened and ventilated to clear it of any possible hydrogen sulfide. Remember that ventilated gas may be hazardous, and that ventilation must be continued whilst someone is in that space. If someone needs rescuing from an enclosed space, you need a monitor to test the atmosphere in the space. You also need resuscitation equipment that does not draw in atmosphere from the enclosed space. All this, plus safe portable lighting and at least one breathing apparatus, together with associated equipment such as harness, lifeline, safety torch and helmet. Before you enter the space, a responsible person must measure the atmospheres and issue an enclosed space entry certificate. A responsible crew member must also remain at the entrance and a system of communications agreed. If hydrogen sulfide is detected or suspected, then self-contained breathing apparatus must be used. The air should be tested for the gas, and crew members must seek advice before entering.
So what would we do if one of the crew is overcome by hydrogen sulfide?
You have to take the precautions we just talked about. Wearing breathing apparatus, you have to take the affected person to an area free of hydrogen sulfide, ideally fresh air. If it's going to do any good at all, treatment must be quick. If the person's not breathing, you must immediately apply artificial respiration and continue until a mechanical resuscitator is available or oxygen brought from the hospital. Continue the treatment until he starts breathing again. If eye contamination has occurred, flush the eyes with clean water for up to 10 minutes. For slight eye irritation, cold compresses are helpful. But the best way to treat hydrogen sulfide poisoning is to prevent it happening in the first place. That must be your number one priority. Remember, whilst hydrogen sulfide is one of the most dangerous gases, it can be managed and dealt with. That means good cargo operation planning and good safety practices to let crew members know precisely what they are dealing with. It also means checking on expected levels of the gas, studying their MSDS, and ensuring all crew members know about the possibilities of hydrogen sulfide being present on board. If in doubt, use your gas detection monitors and wear respiratory protection equipment when hydrogen sulfide is detected. make sure you take precautions when entering enclosed spaces and get your first aid training right. Pay close attention to all these precautions and you'll stop the killer dead in its tracks, rather than let it stop you dead in your tracks.